My name is Kelsey Albert. This is from Homework 1. It's section 1.7, question number 44. And it reads, prove that these four statements about integer n are equivalent. Statement 1 is n squared is odd. Statement 2 is 1 minus n is even. Statement 3 is n cubed is odd. And statement 4 is n squared plus 1 is even. Given these statements about integer n, we start off with statement 1 is equivalent to statement 2. So you start n squared is odd, which means that n times n is odd. And since to get an odd sum, you need any odd integer times an odd integer. This means that n itself is odd, which you can transform into n is equal to 2k plus 1. Okay? Then to get to the 1 minus n part, you rearrange this equation right here to get 1 minus n is equal to negative 2k, which goes to 1 minus n is equal to 2 times negative k. And where k is any integer, that means negative k will be any integer. And since 2 times any integer is an even number, we have proven that 1 minus n itself is even, and statements 1 and 2 are equivalent. Okay? Next, you start by proving that statements 2 and 3 are equivalent. So what you do is you start off with 1 minus n is even, which means that 1 minus n is equal to 2k, because 2 times any integer is an even number, and k here is an integer. Okay? So then you rearrange this into making n is equal to 2 times negative k plus 1. Okay? So once you do that, you prove here that n is odd because 2 times any integer plus 1 will give you an odd integer. So if n is odd, n times n is odd, which means n squared is odd and also an integer. And if n squared is odd and also an integer, that means n squared times n is odd, which means that n cubed is odd. Thus, we have proven that statements 2 and 3 are equivalent to each other. Okay, next you start by proving that statement 3 is equivalent to statement 4. So you start off with n cubed is odd, which you can break down into n squared times n. Okay, so an odd integer times an odd integer gives you odd, like I've said. So this means that n squared is odd, which gives you that n squared is equal to 2k plus 1. Okay, and then get to the n squared plus 1, you take this equation right here and you just add 1 to both sides, so you get n squared plus 1 is equal to 2k plus 2, which can then be factored out into n squared plus 1 is equal to 2 times k plus 1. And if k is an integer, plus 1 will give you another integer, and 2 times any integer is even. Thus, we have proven that n squared plus 1 is even, and statements 3 and 4 are equivalent. Okay? Lastly, we just need to prove that statement 4 is equivalent to statement 1 here. Okay? So you start off with n squared plus 1 is even, which means n squared plus 1 is equal to 2k. Okay? And then if you just subtract 1 from both sides, just so you can get the n squared as stated in statement 1, you get n squared is equal to 2k minus 1. And 2 times any integer minus 1 will give you an odd integer. So thus we have proven that n squared is odd, and that statement 4 is equivalent to statement 1. Thus, we have proven that statements 1, 2, 3, and 4, all about integer n, are equivalent to each other.